Good morning, students. Hope you are enjoying our online teaching modules at your homes and you are fit and fine and staying safe at your home. Yes, students, today we are going to start with a new chapter, that is gravitation. Yes, the various questions comes in your mind, that what holds our earth, our moon, other celestial bodies in the universe, how they are moving, what is the force behind that motion, and various other phenomena also. Yes, students, today we are going to answer all these questions, and in this part we are going to study the universal law of gravitation. Learning outcomes. After the completion of the topic, students, you will be able to define the term gravitation, state universal law of gravitation, identify the nature of force needed for the motion of moon around the earth, define centripetal force, derive the formula for the gravitational force between any two objects, and list the properties of gravitational force and gravitational constant. Yes, students, in this module you are going to learn about the concept of gravitation. You are going to apply this concept in various day-to-day phenomena, like how the apple falls, why not the earth moves towards the apple, and what about the nature of these forces of gravitation, are they attractive or repulsive? We are going to study that. Then we are going to learn about the new force, that is centripetal force, and how it's helped the body to move. Then after the derivation of the gravitational force between any two objects, you will be able to enlist the various properties of gravitational force and the gravitational constant. So, watch the video carefully and check where you have achieved all these learning outcomes. And if you find any problem, then please see this video again. Introduction. In the previous chapters, students, we have learnt about the chapter motion and force. We have learnt about the motion of objects and the force that causes the motion. Now, we have also learned the various effects of the forces, that how the force can change the shape, direction, speed of an object. And in our day-to-day lives, we always observe that the object dropped from the height falls towards the earth, isn't it? We know that all the planets move around the sun. Yes, the moon goes around the earth. But what is there that holds, that do this? Think it over. In all these cases, there must be some force acting on the objects. Yes, students, that force is neither other than less, that is the gravitational force. Its name was given by the scientist Sir Isaac Newton. In this chapter, we are going to learn about gravitation, the universal law of gravitation. Then we will discuss how the object moves under the influence of gravitational force of the earth, and then we are going to differentiate between the concept of mass and weight. Before starting, let's see what are the various topics that have been deleted from this chapter. So please, students, note that from page number 138 to 142 of your NCERT class 9th, these topics have been removed for this session. The first is the thrust and pressure, then Archimedes principle, then buoyancy, and then elementary idea of relative density. So students, let's start with the chapter. Have you heard of the term gravity? Yes. And why we are talking about here? because we are going to study about the gravitational force. Now, what is the difference between the gravitation and gravity? Students, gravitation is the force between any two objects in this universe. But the gravity that we are talking about here, that means the gravitational force, force between the two objects, in which one of the object must be Earth. That is, when we are talking of gravitational force of the Earth, then we say it is gravity. Gravity is the force with which Earth will attract the objects towards itself. Okay. Now this force, you can see here that Earth is attracting every object towards itself. Actually, it is attracting every object towards its center. That is why we say that gravitational force is the central force or center seeking force. Okay. Here the Earth attracts all the objects towards its center. Okay. The force with which this Earth pulls the object, that force is called, yes, gravity or gravitational force of Earth. Okay. And this force is responsible for holding the atmosphere on our Earth, for the rain falling on the Earth, for the flowing of waters in the river, and most importantly for keeping us firmly on the Earth. Okay, the revolution of moon around Earth, all these phenomena are responsible because of the gravitational force only. And before understanding the concept completely, we must know the two forces, that is centripetal and centrifugal force. No doubt the name is new for you, but these are very easy to understand. First of all, just think of the problem when the object is moving in a circle. When object is moving in a circle, then what happens? Yes, its direction of motion is always along the tangent, and it is moving in a circle. Okay, now this happens only when these two forces are present. Firstly, the centrifugal force, it is the center seeking force, and it always acts towards the center around which the object is moving. Okay? When object is moving in a circle, then centrifugal force comes into action. Okay, it will come only when the object is moving in a circle. Okay? It will act towards the center of the object. It will try to hold the object towards its center. Okay? Then centrifugal force. Centrifugal force, what it does is, when object is moving in a circle, this force also comes into action only then, and it tries to move the object outwards, away from the center. It makes the object moves away from the center, and the combination of these two forces helps the object move in a circular path. And you have heard about the meaning of the term tangent. Yes, when the object is moving in a circle, if the central force, the centripetal force is removed, then where the object will move? It will move along a tangent. Then what is this tangent? Yes, we have already learnt here. Also, a straight line that meets the circle at one point, and only one point. Here it touches the circle at point B, and this ABC is the tangent to the circle at point B. Let's start with the universal law of gravitation. According to this law, whenever the two objects are close to each other, or whenever there are any two objects, then these objects will attract each other with a force. Whether the objects are smaller, whether the objects are bigger, these objects will have a force in them, that is the gravitational force. Okay, and this force has certain properties. The properties are, number one, this force is directly proportional to the product of their masses. Whenever there are two objects, there is gravitational force, and that force is directly proportional to the product of the masses. If we multiply the masses, then that force will be proportional to that. Means more is the masses, more will be the gravitational force. Okay, and this force is inversely proportional to the square of the distance between them. Means if r is the distance between these two objects, then the force of attraction, that is force of gravitation, that will be inversely proportional to the square of the distance. Means more is the distance, lesser will be the force, and that force depends upon the square of this distance. Okay, now this is the statement of universal law of gravitation. You have to learn it by heart. That is, every body in the universe attract every other object with the force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now we are going to do the mathematical formulation of this. So keeping in your mind that we are going to denote the force by F and the masses by M1, M2. So if it is directly proportional to the product of masses, then F will be directly proportional to M1 multiply M2, isn't it? Then secondly, force is inversely proportional to the square of the distance between them. Now the force F will be directly proportional to, now it will be 1 by r square. Inverse relation लेना है तो 1 by r, हमें denominator में r में लेके जाना पड़ेगा. Let us see it. How? Now we know that according to the first part of the definition, it is the force is directly proportional to the product of the masses. So I have written here F is directly proportional to M1 multiply M2. Directly proportional means direct variation. More the masses, more will be the force. Now force of attraction is inversely proportional to the square of the distance. Yes, square of the distance means we have to put r square, and inverse means we have to put it in denominator. If F is in the numerator in the left side, then inverse relation means that we have to put this under the denominator. Now what does this mean? If we increase this r, then F will automatically decrease. Inverse है, एक बढ़ेगा एक कम हो जाएगा. Now if we combine these two terms, these two parts of the definition, then we get F, this gravitational force, is directly proportional to M1 M2 over r square. Now in order to remove this proportional sign and to replace it with equal to sign, we always put a constant, and here the constant is g. Okay, so we will write here F is equal to g M1 M2 over r square, where g is constant and we call it as universal gravitational constant. Universal means in the universe, and gravitational constant means this value is constant everywhere in the universe. This is going to be a very important point while we are going to define this term g. So remember, this is universal constant, means constant everywhere in the universe, having same value everywhere. Now, what are the properties of gravitational force? Number one, the gravitational force is the weakest force in nature. Means आपने देखा होगा कि आसपास हमारे काफी सारे objects हैं, but we are not getting attracted towards them, or they are not getting attracted towards us. That doesn't mean there is no gravitational force. Actually, there is gravitational force between you and me, you and your laptop, you and your mobile phone, everything. But that force is so weak that it is hardly to be seen. Very weak. It is weakest in nature. So, कब दिखेगी ये force? Only when the objects are very, very large. Their mass is as large as that of a planet. It is attractive force, means This gravitational force has a nature of attraction only. It will never repel anything. It will always attract. Like electrostatic and magnetic force, these are both attractive as well as repulsive. We have already learned about these forces. The positive charges, similar charges, they will repel. Opposite charges, they will attract. So electrostatic force can be attractive, can be repulsive. And similarly magnetic force also, similar poles, north and north, they will repel, but opposite poles, north and south, they will attract. That means magnetic force is also having attractive as well as repulsive nature. But dear students, note here, the gravitational force is only attractive force. It will never repel. It will always attract the objects. Okay. It is mutual force, means the first body attracts the second body and the second body attracts the first body with equal force. Remember this term, equal force. Means if earth is attracting towards everything towards itself, then other things are attracting the earth also with the equal force. Okay, तो ये प्रॉब्लम हम डिस्कस करेंगे conceptual प्रॉब्लम्स में भी कि कैसे ये इक्वल फोर्स होते हुए भी we are not able to see the motion of earth. We are able to see only the objects falling towards earth, but we are not able to see the motion of earth. We are going to discuss this in this video itself. So watch it carefully. Then it is central force. Central means central, towards acting towards the center. It always acts along the line joining the centers of the body. जब भी हमने distances लेनी है, we are going to take the distances from the center of the body, not from the surface of the body. It is mass and distance dependent. We have seen directly proportional to the product of masses and inversely proportional to the distance. So it is the two factors that on which the two physical quantities on which the gravitational force depends is mass and distance. It obeys the inverse square law. We have seen the distance square in the denominator. That is why we say it as it obeys inverse square law. It is long range force, means it never comes to zero. How far the object may be, jitni marzi dur chale jaye object, this force never tends to be zero. It only tends to be zero at infinite distances. Okay, it is long range force, बहुत दूर तक act करती है. It does not depend upon the medium, whether the medium is solid, liquid or gas or vacuum, then it also the force remains the same. It does not have any effect of the medium. Now this gravitational force is responsible for the tides formation also. You know the tides, very high movement of the water, and these happens at a particular time of the day. Yes, you have seen the tides, but during full moon and new moon day, these tides are the highest one. Do you know the reason why the tides are highest? First of all, understand this term, that the gravitational force between the earth and moon causes these tides. Tides happens because of the gravitational pull. Okay, and the gravitational pull of the moon as well as of earth as well as of sun also. Dear students, note here, sun also. Whenever the moon, earth and sun, all the threes are aligned, it happens during new moon and full moon day, they are aligned. Whenever they are aligned, then the gravitational pull of the sun adds to that of the moon and causes the maximum tides. So during new moon day and full moon day, the tides are very high because the gravitational pull of the moon as well as the sun adds up. Spring tides happens when sun moon are on the same side of the earth, that is new moon day, and when sun and moon are on the opposite sides, that is on the full moon day. So particular these days the tides are high. Okay. Importance of universal law of gravitation. अब हमने सारा पढ़ लिया इसको. Let us summarize the importance. Number one, the phenomena of this gravitational force of attraction. This explains the force that binds us to the earth. Okay, this is the gravitational force only that binds us to the earth. The motion of the moon around earth, it is also because of the gravitation force and the motion of planets around the sun. And the tides, अभी हमने देखा है इसको पढ़ा, the tides due to the moon and the sun. Okay, all these phenomena are successfully explained by the gravitational law. These are explained successfully by the universal law of gravitation. Now we have seen that F is equal to G m1 m2 upon r square. Now let's explore this G. This is gravitational constant, capital G. If we see this formula from here, you can write the formula for G. We'll take this r to the left side, f r square, and this will go in the denominator. So we get G equals to f r square upon m1 into m2. Now what about this G? This is universal gravitational constant. Note the value of G. It is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. Students, ये वैल्यू आपने अच्छे से लर्न करनी है और ये वैल्यू G की कांस्टेंट रहेगी in every numerical, everywhere in the universe it is constant. It is never going to be changed. The value does not depend upon the medium between any two bodies. Okay, the value of G is same. The universal gravitational constant G is different from the acceleration due to gravity. Dear, we are going to study about the G, small g also, that is acceleration due to gravity, and this capital G is different from that. So abhi se samajh lo, this G is constant throughout the universe. This G has a fixed value. It will not depend upon the medium of the size. किसी पे भी dependence नहीं है इसकी. And SI units of G is here Newton meter square per kg square. If two bodies of mass 1 kg each are separated from 1 meter, means if we take all these terms 1, distance is also 1, masses are also 1, unit ले लिया 1 kg and distance is 1 meter, then G will be equal to the F. Okay, everything, rest of the things are 1, then G will be equal to F. Therefore, universal gravitational constant G can be defined here. This G, please note here, universal gravitational constant G will be equal to the force of gravitation which exists when two bodies have the unit mass and they are separated from each other by the unit distance. Unit means 1. So we can here define capital G as the gravitational force between the objects of unit masses and they are separated by the unit distance from each other. So students, let's check, have you obtained your learning outcomes? Yes. Can you define now the gravitation? The force of attraction? Yes, it's not repulsion, it's only the attraction between any two objects. State the universal law of gravitation. Yes, we have learned this, that F is equal to G m1 m2 upon r square, and this universal law says that force between the two objects is directly proportional to product of the masses and inversely proportional to square of the distance between them. We have identified the nature of force needed for the motion of moon around the earth. Yes, we have seen that centripetal and centrifugal forces. Now you can define the centripetal force, center-seeking force, and we have seen the derivation of gravitational force between any two objects, and we have derived the formula F equal to G m1 m2 upon r square. Now we can enlist the properties of gravitational force and gravitational constant. अभी हमने की properties of gravitational force is the force that is responsible for the motion of earth around sun, motion of moon around earth, then the formation of tides, then this force is always attractive, central force है ना. Gravitational constant we have learned about, this is universally constant, it has fixed value, it will not depend upon the medium between the objects. So students, we have learned all these outcomes, and just watch the video so that we are able to attain all these learning outcomes, and we are able to solve the numericals based on them. Let's see, first of all, the concept based question. In this question, we are going to combine the Newton's second law, Newton's third law, and the law of gravitation. We have already studied all these things now. Let us see. According to the Newton's third law and universal law of gravitation, what happens? Every object attracts each other. ये है universal law with gravitational force, and these forces are equal and opposite. This is Newton's third law. Okay. Now think of the problem that apple is falling towards earth. We have seen that whenever the apple is seen falling towards earth, we are not able to see the earth jumping towards the apple. हमने तो सीखा कि it is the gravitational force is the mutual force, equal and opposite force. Then why not earth is moving towards the apple and we are only seeing the apple falling towards the earth? For this, let's clear this. From Newton's second law, we know F is equal to ma, and for the apple it will be ma. Here m is mass of apple and a is acceleration with which it is falling. Okay, and for earth it will be, again the force F will remain same because it is equal and opposite force, so we will take it as F only. It will be ma. Here m is the mass of earth and a is the acceleration with which the earth must move towards the apple. Okay. Now from Newton's third law, these two forces are equal and opposite. So if we take only the magnitude, we are not concerning about the sign, we are taking the value only. So F will be equal to ma, both the forces are equal. Now from here you can see this ma equals to ma. For the given force, what you get is A equals to F upon m, or capital A will be equal to F upon capital M. Now here m is the mass of the apple and it is very less than that of the mass of earth, isn't it? So m is less, so A will be more. Inverse relation है इनका, हमने अभी सीखा है इसको. ठीक है. For the given force, denominator में अगर value बहुत कम है, the value of fraction will increase. So acceleration is very large. M is small, acceleration large. But for the in case of Earth, M, the mass of Earth is very large, very large value. So M is very large, denominator is large value. So fraction will be very less. This fraction is equal to the acceleration. So acceleration will be negligible for the earth and we are not able to see the acceleration of earth because of the great mass. Hence, acceleration of apple is far larger than that of the earth. Now here is the task for you. Try to find out the answers of the following questions and write them in your notebooks. Thank you, students. Enjoy your learning at your home. Stay home, stay safe. Thank you.